Crazy Dr. Krause here, talking in this segment about cardiovascular physiology primarily, but let's face it, to understand cardiovascular physiology, you have to understand cardiovascular structure. So that means you need to review things like this: anterior view of the heart, posterior view of the heart. Where are you? There you are. Posterior view of the heart. Posterior view of the heart. Anterior view of the heart. Particularly this interior view of the heart. Because one of the things that gets emphasized in cardiovascular physiology is blood flow through the heart. If you don't understand the four chambers of the heart, four valves of the heart, major vessels draining into the atria, major vessels that carry blood out of the ventricles, you're going to have a hard time understanding that blood flow. So review your cardiac structure, your cardiac physiology. That's certainly something you have to do before you even take a look at the cardiac physiology. And then in super simple, there's this wonderful diagram, flow chart, that relates the cardiovascular system to a transportation system. Remember, RevCam, one of the keys to learning is association, being able to associate new knowledge with existing knowledge. So the existing knowledge is all of us understand a transportation system. We use it day in and day out. And transportation systems have some kind of a vehicle. Might be a bus, might be a Bentley, might be a Honda, might be a bicycle. And then there's some kind of an engine providing energy to move that vehicle. That might be an internal combustion engine. It might be an electric motor on the bicycle. It's whoever it is, you or me, pedaling the bicycle. And then those vehicles run on highways or in tunnels. And in the cardiovascular system, the vehicle is the blood. The engine providing the energy is the heart. And the highways are the vessels, arteries and veins. So that's a good place to start. You ought to understand a little bit about blood composition, and this will help you with blood composition because it talks about it over here. Blood composition. It's 45% red blood cells. Why so many red blood cells? Because of what they do, which is carry oxygen. Why is oxygen important? Because it's essential for the sustainable production of cellular energy, stored in the form of ATP, produced through CMCR. A little review there. You need to remember arteries and veins are structured differently. They're structured differently because of what they do. Arteries have thicker walls, more muscular. They can control blood pressure and they can shunt blood from one place of the body to another place, whereas veins are thinner walled, less muscle. Veins have valves to maintain one-way flow back to the heart, whereas the arteries do not have veins, and that distinction is many times tested. And then one of the fun things, but also one of the most confusing things in cardiovascular physiology, cardiac cycle. You need to know the cardiac cycle, what it is. It is a representation of all of the events occurring in a single heartbeat, in a single lub-dub. And actually it's six graphs superimposed on each other. 3 of those graphs relate to pressure. Pressure in the aorta, pressure in the ventricle, pressure in the atria, and we're talking systemic or left side of the heart, because that's the higher pressure side, about 10 times higher pressure than what we find in the right side of the heart or the pulmonary circuit. Then there is a graph showing ventricular volume, including end diastolic volume or EDV, and systolic end systolic volume, ESV. A fifth graph shows the electrical activity in the heart, an EKG. EKG doesn't show mechanical activity in the heart. It shows electrical activity, which initiates mechanical activity, contraction of the heart. And then the final graph is a phonocardiogram showing heart sounds. S1 caused by AV valve closure, S2 caused by semilunar valve closure, and an S3 and an S4 extra sounds. S3 would cause what's called an S3 gallop. Lub da boop, lub da boop, lub da boop, lub da boop, lub da boop. It's a sound in early diastole that's associated with rapid ventricular filling that causes blood turbulence. And that's a really important concept in cardiovascular physiology, to understand that with an occasional exception, like there are to most general concepts, if you're hearing something other than an S1 or an S2 caused by valve closure, it has to be caused by blood turbulence. So a mid-systolic murmur, lub stub, lub stub, lub stub, lub stub. That's an extra sound caused by blood turbulence. There's something. Could be aortic stenosis, could be mitral valve or left AV valve insufficiency, but don't go there yet. Don't try to come up with a specific diagnosis. This isn't a pathophysiology endeavor. We're talking about normal cardiovascular physiology. If there's a sound other than S1 and S2 over the heart, over the common carotid artery, over other vessels or areas that you might auscultate with a stethoscope, over vasculature, and there is a sound, it's because something is causing the blood to tumble. The cause is blood turbulence. So normally if you auscultated a common carotid artery, big artery going up to the head and neck, you remember, might be good to review your major vessels as a part of that heart structure in chapter 11 in Super Simple. If you auscultate that common carotid artery in a healthy person, you're not going to hear anything because the blood is flowing in a straight laminar pattern. Fluids that flow in a laminar pattern don't make noise. But if you auscultate that common carotid and you hear psh, 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 it's called a carotid bruit, B-R-U-I-T. There's something causing the blood to tumble. It could be a narrowing of the artery, plaquing, arteriosclerotic cardiovascular disease. That might be one of the most common causes. Could be an aneurysm, where the vessel is expanding or ballooning in one wall, which would cause turbulence as the blood flowed through that widened area and then back to the normal diameter of the artery. Could be a tumor, a thyroid tumor, parathyroid tumor that's grown large enough that it's putting pressure on that vessel and narrowing it. That would cause the blood to tumble. So basic concept, remember, sounds other than S1 and S2 are caused by blood turbulence, with an occasional exception, an opening click, but we won't go there. Those types of exceptions you can learn in pathophysiology and as you advance academically and in your career. So cardiac cycle, that's a big one. If you really want to understand EKG interpretation, by the way, and at this level you really don't. You need to know an EKG is a graph showing electrical activity in the heart, starting at the SA node, going to the AV node, going down the AV bundle into the left and right bundle branches and out the Purkinje fibers. And that electrical depolarization of those specialized fibers causes the heart muscle to contract. But when you get it to a point where you want to or need to be able to interpret EKGs, I just want to mention Dale Dubin's rapid interpretation of EKGs. Single best medical text that I have ever seen. Rapid interpretation of EKGs by Dr. Dale Dubin, D-U-B-I-N. You can look it up on that there internet. And that's about it. Cardiovascular physiology. Remember, you've got to understand the cardiovascular anatomy to be able to appreciate the cardiovascular physiology, including and in particular the cardiac cycle and the normal flow of blood through the hearts. You ought to be able to start in the right atrium and take a red cell out to the lungs, back to the heart, out to the body, back to the heart. So right atrium, right AV valve, right ventricle, pulmonary semilunar valve, pulmonary trunk, left and right pulmonary arteries, left and right lungs, where oxygen is given up and carbon dioxide is given up, oxygen is absorbed, back to the heart through the 4 pulmonary veins, 2 from the left lung, 2 from the right lung, into the left atrium through the left AV valve, the mitral or bicuspid valve, 3 different names, you need to know them all. Left ventricle out through the aortic semilunar valve to the aorta, immediately out through the left and right coronary artery, feeding oxygen-rich blood to the myocardium, continuing up the ascending aorta to the arch of the aorta, brachiocephalic trunk, left common carotid, left subclavian arteries, down the descending aorta, out to the rest of the body, and then back to the heart through the superior vena cava, inferior vena cava, and the coronary sinus, which drains oxygen-poor blood from the myocardium back into the right atrium. You ought to be able to do that comfortably without having to look anything up, much like I just did it. So spend some time. Remember, you got to churn to learn. And I'll see you when we talk about immune system or whatever the next topic happens to be. Until then, stay healthy. Kraus out.